Hey, welcome back to your favorite trigonometry class. We're going to look at the hyperbola today. Here's our objectives. Let's start out with its definition. So here's what a hyperbola looks like. This is called the transverse axis, where the focus and the vertices lie. You notice that the vertices lie on the hyperbola. They wrap around our focus points there, right? They wrap around. This is called our conjugate axis right here. It also goes through the center. That's perpendicular to the transverse axis. Now, the definition of a hyperbola is a collection of all points whose difference of distances from the two fixed points called the foci is a constant. So here's a look at that. So if you look at the distance from, so let's take this point xy that's on the hyperbola, okay? This distance right here from F1 to P minus this distance from F2, that focus, to P is a fixed constant. So it's the collection of all those points that are a fixed, whose difference is a fixed amount, right? The hyperbola makes up all those, right? If I put the point over here, that distance minus that distance is also a fixed constant k, which is the absolute value of 2a. So let me show you how that works here, how that 2a comes about. If I put this point P right here, okay, and let me give you some points on a hyperbola here. If your center's right there, your distance to the vertex, one of the vertices, is A. The distance to the focus is C. Okay? So if I move this point down here to P, then this total distance would be the C plus A. Okay, so the distance from F1 to P minus the distance from F2 to P is a fixed constant K. We're going to find out what that is. So this distance is C plus A. So C plus A minus, now the distance from F2 to P. So the distance right here. Okay, we know this distance is C. We know that distance is A, so it's just C minus A. So when I distribute that, notice my C's cancel and I have A plus A. So that my fixed amount is 2A. So the difference is 2A, the absolute value of 2A there. So distance there, right? It's the fixed distance. So that's just a little note of that. That'll come into play in our application problem at the end. So the equation, if you've got a hyperbola that opens right and left, its center's right there in the middle, its focus, it's focused to C distance away, but its vertex is A distance away, right? So here's A0, these are my vertices, here's negative A, 0, so again this distance is A for the vertices. And it's going to wrap around our focus points, which are C distance away from the center. Okay, here's the other focus point. Okay, then this is our equation: x squared over a squared minus y squared over b squared equals 1. And this is the relationship between a, b, and c. So b squared equals c squared minus a squared. Okay. Now, in addition to this, you should be aware that the way that you draw how wide this opening is, the asymptotes help you to draw how wide that is. So here, let me give you a little picture of the asymptotes. So the asymptotes go up B and over A in this case. So the B distance, so if you can imagine um, an imaginary, you notice the dotted rectangle here. If I go up, this is the B amount that comes from that right there in the equation, the B value. And we know this is an A amount, so if I go up B and over A and I put a dot to make this rectangle, and then I go down B and over A and I put a dot, and I draw this asymptote, and that asymptote is up B over AX. That's the equation of that asymptote. And it helps me to draw my hyperbola, how wide that mouth is, if you will. And then the other one is down B over A. So this one is going down to the left, would be down B and over AX. That's the equation of that one. Okay, so that imaginary rectangle, if you draw, if you extend lines through the diagonals there, so the extension of the diagonals of the rectangle are the asymptotes. Okay, so in other words, they're asymptotes, so as you go out further and further and further, it gets closer and closer and closer to the asymptote. The further it goes out, closer it gets to the dotted line, the asymptotes. Okay, so again, you want to remember this relationship. You want to remember for if it opens right or left and the center's in the middle, b squared equals c squared minus a squared, and then the asymptotes. We'll run through examples. Plus minus b over ax. Okay? Alright, let's run through some examples. Find equation of hyperbola with center at the origin. One focus at 4, 0. You guys know I like to make these visual. 1, 2, 3, 4. So here's one of the focus. And we know the center's right there at the middle. So we already know that's our C distance is 4, right? We have a vertex at negative 3, 0, so they just gave us the A value. Oops. A value, so A is, oh my goodness, come on. A is 3, okay? And if one of the focus is at negative 3, 0, the center's right there in the middle. You know the center's right in the mid, is the midpoint of the two, between the two vertices. So I know my other vertex has got to be at 3, 0 as well. If the other side is negative 3, 0. If I know one of the focus is a 4, 0, I know the other one's at negative 4, 0, and it kind of wraps around the focus. It hits the vertex, but it wraps around. Okay. So what I'm going to do is I'm going to say, let me write this out. I know A is 3. I know my C is 4. And I know the relationship is B squared equals C squared minus A squared. So B squared equals 4 squared minus 3 squared. B squared equals 7. So B is plus or minus root 7 here. So what I'm going to do is I'm going to use that to write the equation of my hyperbola. So I have x squared, if it opens right left, it centers right at the middle, it's x squared over a squared minus y squared over b squared equals 1. And I have my a, it's 3, so 3 will be squared. I have my b now, it's root 7, which will be squared. So I have x squared over 9 minus y squared over 7 equals 1. That's the equation of the hyperbola. Now, how wide is this? And give me another point. First of all, let's find the point, and then we'll talk about how wide it is. I'm sorry, we'll find the asymptotes. So let's find a point above and below the focus, the foci. So here's the focus right here at 4, 0, right? It's at 4, 0. And then the other one's over here at negative 4, 0. So I'm going to let x be plus or minus 4 so that I can find, I want to find this point and that point, and that point and that point, right? So my equation, x squared over 9 minus y squared over 7, so x squared is plus or minus 4, x squared over 9 minus y squared over 7 equals 1. So I got 16/9 minus y squared over 7 equals 1. So I have y squared over 7 equals, what was that, 7/9. All right. Multiply both sides by 7, so y squared equals 49 over 9. Square root, I got plus or minus 7/9. Okay, so I'm up Oh, I'm sorry, I didn't square root the 9 plus minus 7/3. So I'm up 2 1/3. 1, 2 1/3 is where that point is. So, in fact, let me write the points. I have plus or minus x is, when x is plus or minus 4, I have both 7/3 and I have negative 7/3 for my y by. So here's 4 comma 7/3. Here's 4 comma down 2 1/3. Here's negative 4 7/3. Here's negative 4 negative 7/3. So there's some points. There's some points, right, on the hyperbola. On the hyperbola. Okay. Now the last thing I want to do is I want to draw my asymptotes. Let's see if I have a little room here. My asymptotes. Asymptotes. So the asymptotes, we know that b is root 7. Okay, that's on my conjugate axis. Now root 7 is between root 4, which is 2, and root 9, which is 3. So it's between 2 and 3, it's like 2.6-ish or so. Okay, so what I'm going to do is I'm going to go up b and over a. And I'm going to make this rectangle. So I'm going to go up root 7. So this is root 7. I'm going to go over 3. And that's one corner of this rectangle. And then I'm going to go down b, down root 7, and left 3. And that's the other end, the opposite corner, if it'll let me draw it. Stupid thing, come on. There's the other corner of the rectangle. I'm going to go up b, left a, put a dot, down b, right a, put a dot. Okay, here's my imaginary rectangle, if you can draw it, but it goes through the corners there. Oh, come on. Dude, for the love. There we go. Goes through the corners there. And that just kind of helps you draw this hyperbola. I know I'm not the greatest drawer here. Whoops, I didn't write that down. Y equals plus or minus b over ax. So y equals plus or minus root 7 over 3x are the equations for both of those asymptotes, right? They're dotted lines. They should be dotted lines, but I have a hard time drawing those things. Okay, here they are. Again, there's your asymptotes that we kind of drew to kind of help us draw how wide it is. Okay. All right, let's do some more here. We got x squared over 25 minus y squared over 9 equals 1. So we've got number 1, we're like, hey, this is the transverse axis is again along the x-axis. The center's right in the middle. So this is telling us if a squared is 25, I know a is 5, b squared is 9, b is 3. So the transverse axis is along the x-axis. So it goes through, if I can make a picture of this, goes through right through the center. Okay? And then the a distance is going to open right and left. A distance is 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I'm going to put the point for my vertices here. And I also know my b here is 3. I might as well draw my imaginary rectangle here. My b is 3. That helps me draw how wide this is, because now I have my asymptotes through the corner of that. Okay. Now, what else do we need? Well, so here's my number 2. I made a visual. Number 3, we know b squared equals c squared minus a squared. We know b is 3. We know our a is 5. So C ends up being, or C squared ends up being 34. So we got plus or minus root 34. So it's between 5 and 6. So it's about right here's our focus. The other one's about right there's our focus. That's our vertex, right? So now's our C. So if we're going to get the point above, below foci, let's let our x be root 34 plus or minus. Okay, so now we got plus or minus root 34 squared. So we're using this equation right here. Over 25 minus y squared over 9 equals 1. So we got, let's see, that ends up being y squared over 9 equals 9 over 25. Multiply by 9, y squared equals 81 over 25. Y equals plus or minus 9 over 5. So that gives us the points, 9/5. So, 1 4/5 are my points above the axis. So when x is, so the points, plus or minus root 34, comma, I'm just going to write plus or minus 9/5 here. So root 34, so 5 point something, and I'm up 1 4/5, almost 2 right here. So this is kind of showing us this negative root 34, I'm up 1 1/4. Negative root 34, down 1 1/4, hitting that vertex. I didn't draw that very well, but you kind of get the idea. And then, yeah, so that's that. Our asymptotes are up b over a, so our asymptotes, if you want to write those, asymptotes plus minus b over ax. So in this case here, we're up b 3, we're over a 5, plus minus 3/5 x. That's the equation. There's y equals 3/5 x. There's y equals negative 3/5 x. The asymptotes for that. All right, I'm gonna show you a picture here, or the work on that one. There's a little picture as well, except without our asymptotes. I should draw those dotted lines here. All right, that's a good place to stop. Let's stop right here.